record. I'm trying to go eat chili with my roommates.
Okay.
Is it recording?
Mm-hmm.
I did not know.
Yeah.
Hey, I'm Melissa.
And I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life, even in a national crisis.
Even in a national, that's true. It's a national state of emergency.
Mm-hmm.
Yes, we're in the midst of Corona this week.
Mm-hmm.
We've just had lots of major changes, but luckily we're still here for a fun Q&R bonus episode.
Yes. And maybe you've got a little bit of extra time to listen to podcasts or something. So if so, then here you go.
Woohoo. But we do, though, want to encourage everyone to take precautions, wash your hands, don't buy all the toilet paper, leave some for other people.
Including us, please.
Including us. My roommates are running out,
Mm-hmm.
so it's a little dangerous.
Yes, do everything you can, stay safe,
Mm-hmm.
and because we care about you guys.
Yeah, that's so true. Okay. Before we start,
Okay.
I want to do 2 comments.
Okay.
Corrections.
Corrections. I was gonna say, aren't they corrections? I mean, like,
One's a correction.
okay.
So my first correction was pointed out to me is before seminar. We have seminar every week in the chemistry department. And my friend Tim, or Timothy P., he pointed out to me something, and I don't know how I didn't know this, but he said methane doesn't have a smell. Manure produces methane, but that's not the thing that has a smell. And actually, natural gas is often engineered with sulfur compounds to smell so that we will notice it.
Oh, that is interesting. I actually think I'd heard that somewhere, but I don't know if I knew which things had it and which things didn't.
I had never heard that, and I don't know how I didn't know. I mean, if I had stopped and thought, I would have realized that that is accurate. It doesn't really make sense that methane has a smell.
Mm-hmm.
But I did a quick Google check, and Google confirmed what he said to me.
Mm-hmm.
But the question originally asked was, are there things that smell bad that aren't sulfur compounds? And I said yes, and I gave methane as the example, which was wrong. So I want to I love learning new things, which sometimes means admitting that you're wrong.
Yeah.
So I wanted to come here and confess to you guys that I was wrong and tell you that my overall answer was still right, because I think there are other things that I think smell bad that don't have sulfur in them. For example, there's a thing I used in the lab a lot called acetophenone, and that's just a common name for it, but it's just a carbon and carbon, hydrogens, and oxygen only, and it smells to me exactly like a women's public restroom. I think it smells so bad.
Ugh.
Yes, a women's public restroom at like a park. There's a specific gross smell to that. So that one has absolutely no sulfur in it, and it still smells bad. So my point remains, but I was wrong about the methane. So I wanted to come here and be honest about that and admit when I was wrong, because I think that that's really important to do.
Yeah.
That's a lot of science. And the other thing, I wanted to shout out Tori M., because she has given us so many good questions. But Tori, they're all questions that I don't actually know the answer to. You just consistently stump me, and I haven't had an abundance of time to research them yet. So thank you for sending us those questions when you wonder about them and are thinking through them. I just think it's so fun. She asked us a question about cheese and a question about wine, and she just has really great questions, but they've stumped me. So I'm going to need some time to research them before I can make them into an episode.
That's good.
And the rest of you, Tori really is killing it. So you can
Up your
follow
game,
her
guys.
lead. Yeah.
That is very Tori, though, to ask a question that is very much worth asking, you know?
Yeah.
Like to really hold them like, I don't know, and then only ask really killer ones.
Yeah.
This will get her. That's kind of...
They have every single... She's, I think, submitted 4 or 5 in every single one, I think. Gosh, I don't know. That's a great question.
Yeah.
So just wanted to shout out Tori M. for that.
Okay, are you ready for the question portion of the question and response?
Yes, I am.
Okay. So this question is in regard to the bleach episode.
Oh, I did want to include, so when we edit through our episodes, we try to keep them to a reasonable amount of time.
Yeah.
And we had so much fun talking about some stuff from the bleach episode that it was very long, about 10 minutes longer than the final product.
Yeah.
But we cut some really interesting stuff about the way we use the same detection for color in the lab as we do in our eyes. Is sort of, we've computerized that. And there's a part that I really wanted to save and include. So we're going to go ahead and play that clip for you so you can hear what we missed. And we use this technology in the lab. I worked on photosynthesis, artificial photosynthesis, and we made it's called conjugated. So very high numbers of alternating double bonds. It was that beautiful teal colored liquid that I put on the Instagram before. That has a lot of alternating double bonds in the structure. So it absorbs light in, it would be the complementary color. So I guess the red, orange area. And then it reflects back that beautiful teal color. And to determine at exactly what wavelength it absorbed light, we had an instrument that put light into it. You have a little sample size for the molecule itself, and then there's a detector that feeds information back to the computer. So it almost works like a computerized version of our experience.
Oh, interesting.
In an isolated box, so there's no interference, and it can tell you exactly what energy the electrons are exciting to and absorbing.
Wow.
So we use that technology a lot.
Yeah. That's crazy to think that exists. Like, I just don't even know the first place to start in terms of being able to actually measure light in a way that's not just like subjective. Well, like we obviously can say like, oh, that looks orange or whatever.
Right.
But how do you then get a computer to do it? Man, that's crazy to think about.
Right. Inherently, one of the articles I read said that inherently color is very subjective because the light can change. Our eyes can maybe interpret things differently. The molecules in different environments, like warmer or cooler, can change. So color can really change a lot. But when you hold those factors steady in an instrument, it actually shines light from the entire visible spectrum. That one went all the way into the UV spectrum. And so it would control the wavelength at which it was shining light. And then that light would pass through the sample. And the detector on the other side would determine which wavelengths were getting through and which wavelengths weren't getting through. And the ones that weren't coming through the sample were being absorbed by the sample.
I just realized I'm kind of dumb.
Why?
Well, I just started thinking about like computers being able to see light and stuff like that.
Right.
That's exactly how we tested people's water at the pool store. It was based on light.
Wow, you did an absorption?
Yeah, we did. We had these vials that had chemical, like specific powders in them that should react with the people's pool water in different ways to test different parameters of their water. So pH would be 1.
Right.
And then just how much chlorine they have in there already that's like still there that didn't get like, evaporated by the sun or whatever.
Right.
And how much has changed based on like it raining or whatever. We had like 5 and how much acid, all these things, like 5 or 6 vials. And then you put them in the thing you shut and you would run it and it would shine light in each one.
Right.
And determine it, like its level based on the light. So
Yes.
I've done that and didn't even think about it. And I just said like, oh, wow, wouldn't it be cool if computers could do that?
But computers can do that.
And I did it. I
That's
didn't know how it worked
amazing.
exactly, but I knew that much.
So actually, and I decided to not get into this because I thought it was going to be boring. But since you said that, I'll tell you. Actually, you can use the absorption of how much light is absorbed to determine the concentration of something.
Okay.
So there's some limitations to it, but if you have a higher concentration of a molecule that absorbs at X nanometers versus a lower that absorbs at X nanometers, the computer can shine the light and you can plug all this information in to find out what the concentration of your solution is.
Yeah.
So that's probably exactly what you were doing in the pool store.
It must be.
And you put it in the thing and closed the box. So it was an isolated area where you had the light and the molecules and the detector. Yeah.
And then we'd print off a sheet that was like, hey, here's the results. And then we'd go from that basically to diagnose their pool. But we had to have the computer obviously do that first part because it would just be guessing if we just did it on our human,
right. Our computers are not standardized in our brains. Our brain computers are not standardized the way we force computer technology to be standardized. So your eyeballs would not be an effective detector to send information back to your brain in an objective manner.
Yeah. Gosh, that's crazy.
That's a really cool tidbit. I appreciate you sharing that.
It just like suddenly rushed back into my head. We don't have to put this in, but like you know how that happens where like suddenly all these memories come back? Okay, we are back in the present, which
That was
will
a little fun.
which will very very quickly be the past. So the question from the bleach episode that we have is from Stephen H. And he asked, is the oxygenation reaction from bleach reversible? I.e., is the color hiding in there in such a way that it could be brought back? Like, say, in a hoodie of some kind that you get a little bit of bleach on.
That's an interesting question. So my answer is chemists, organic chemists especially, are pretty powerful. They can do a lot with things. I'm not sure if that reaction specifically would be easily reversed to exactly what it started out as in the context of it being in your hoodie. But if I had that molecule in the lab and I had oxygenated it and then I wanted to reverse that, I would have tools to be able to do that. But when it's already been processed, purified, put on, and dyed into your cloth material, I think it's going to be a lot more challenging to reasonably carry out the reverse reaction.
I see what you're saying. Yeah.
And it would not even necessarily be like, so we go from A to B, and then we can use a reverse reaction to go from B back to A. We might have to do several steps to get all the way back to what it started out as.
Like from B all the way through Z and then back to A.
Sometimes. Organic chemistry is very weird sometimes. Yeah. So I don't know the exact details of that specific reaction, how you could reverse it or what you could do to make the color come back. I would be surprised if it was impossible, but I would also be surprised if it was very simple.
Yeah.
I imagine that process being a multi-step reaction sequence to get back to where you started.
Wow.
But I didn't look into it specifically.
Gosh, that's crazy. That'd be way cool if it was that simple.
Yeah. Some reactions are, just not this one.
This next question is also about bleach. It's from Alice C.
That's my mom. It's from my mom. This is so exciting.
I wonder what the C stands for. Cannoli. I have heard that soap and bleach can cancel each other out. Is that true?
I think she means laundry soap, like laundry detergent, and bleach can safely be mixed. They've been chemically formulated to mix.
Okay.
And not produce any dangerous byproducts.
Good.
But I would not be shocked based on the chemical structure of bleach and the chemical structure of most soaps and detergents if the two interacted with each other in a way that somehow made both of them less effective.
Interesting.
So you can mix them and it's safe and fine. But I think it'd be more effective if you soaked it in bleach first, then did a rinse cycle and did soap.
Interesting.
Would be my suspicion because I suspect that the two could interact and change the chemical nature and make both of them less effective.
Interesting. Yeah, I've usually done both bleach and soap because I think of bleach as like the main thing about it is just for making whites whiter and brighter.
Yeah.
And then the soap is like, oh, got to make it clean too. I've never thought about that they might like make each other a little bit less good at those things.
I think that's a real possibility. Although I have not admittedly looked into laundry detergent chemistry.
Can bleach on its own clean a little bit? Like if I just did bleach? Or is that not enough? I've always felt like it wouldn't, but never really looked at it.
Yes, actually it can.
Huh.
So bleach breaks up those molecules, the conjugation in color like we talked about. And it can also break up those molecules in dirt. And that will make it easier for them to be lifted and washed away. But also adding oxygens or chlorine will make it more willing to interact with the water. And that can also help things wash away too. So bleach can take away color, but it can also help take away dirt. But I think things that are washed with dish soap smell better. Personally, I said dish soap, but I meant laundry detergent. Smell better. I don't wash my clothes with dish soap. Listeners at home, my clothes smell good like Tide and... Wait, is it Tide? Yeah. Tide and fluffy clean laundry, not like dish soap.
Right.
No, it's true.
Totally.
So I personally think you can always hit it with a little bit of laundry detergent to make it smell better, but I don't know for sure.
Or just throw some mints in there. Anyway, moving on.
Yikes.
These next few questions are from the hand warmer episode, and they are all from Stephen H. So
Stephen H. asks really good questions
Mhm.
that are easy to answer and very relevant. That's why he gets a lot on
Mhm.
here.
Well done, Steven. No, they are really good. I don't think we've ever had a not good one from him. He's even been one of the ones to do some non-chemistry questions, which have been good. So
Yes.
his first one is this: is all crystal formation exothermic?
Yes.
Holy.
So it's hard for people to think about that, but something going from a liquid to a solid is letting off heat.
Mm-hmm.
So going from a less ordered state to a more ordered state is always exothermic.
That makes sense. And you did say that the other day. It's kind of cool how he asked it, and I did not, for some reason, didn't expect it to be yes.
Mm-hmm. And also that means that, and he brought this up to me in person, that making snowflakes is exothermic
How?
because it's going from a liquid to a solid.
Oh, yeah. Yeah. It's trippy.
It is kind of trippy.
His next one is this. If the supersaturated fluid in these reusable hand warmers we talked about, if you missed that episode, go back and check it out. If the supersaturated fluid wasn't sealed in a pouch, would it form crystals in the same way? I.e., is there anything special about being in a sealed container?
No, I don't think so, because we've seen that happen. I mean, I talked about when you scratch the side of a glass, the crystals form immediately, stuff like that. So I think the answer to that question is no. The sealed pouch I don't think matters. In this case, I think it keeps it from the liquid evaporating when you boil it.
Right.
And it keeps it in a pouch you can carry with you, but it's not key, I don't think, to the crystallization process, only key to the function of the hand warmers.
Okay, yeah, that makes sense. Stephen's third and final question about hand warmers is this.
Also, Stephen came up with the idea for that episode, so I think he really was invested.
Yeah, really, truly. I tried boiling one of our hand warmers to reset it, and it seemed to turn back to liquid, but there was still some crystals in there once it cooled. Does this mean I didn't boil hot enough, long enough, or both?
Okay, Stephen. The same thing happened to me. I posted an Instagram story where I was reboiling those two hand warmers, and one of them was still liquid when it cooled down, and the other one recrystallized a little bit.
Huh.
So I took it back and put it back in the boil and boiled a little bit longer and brought it back out, and it stayed liquid that time.
Got it.
And I think we can't really say for sure. I think boiling it longer will solve the problem. Just put it back in there and boil it more. Could be because there's different colored dyes in them. It could be because there's slightly different amounts of liquid. It's not standardized. I don't really know exactly why. I put them in together at the same time. They boiled together for the same amount of time, and one was liquid and one went back to the crystal form. So it just was something about the way it happened. It was able to seed and sort of form the crystals as it settled back out and cooled down. Boil it a little bit longer and it should go more into solution and fix the problem. But that did happen to me too.
Yeah, that's interesting. So was it, well, I guess it was hot because it was just in hot water. So
it cooled back down and crystallized. You can't tell until it's cool if it actually worked.
Got it. Okay.
Like if I boil something and it comes back down to room temperature, it could crash out. We call it crashing out of solution.
Oh.
Because it's not soluble in that liquid at room temperature.
Got it.
Unless you form a supersaturated solution that's not disturbed or all that stuff to stay liquid.
Okay, here is our last question. This question came from Instagram, and it's not regarding a specific episode. It's from Jonathan the White on Insta. That's his username. Is using a steam mop to clean your floors as effective as using traditional detergents?
Okay, Jonathan, I have a lot of thoughts about this.
Oh, interesting.
Detergents are soap. We've talked about that in the first episode, about how it forms those cells, sort of circles all around the dirt and helps it to be comfortable with water and wash away. So that's important, and it is effective. However, steam can be more disinfecting, and it can also break things up like dirt on your ground that's just stuck on because it's hot.
Oh, yeah.
So I think that both are really going to be good for different reasons. Detergent is going to help you clean the greasy spots a lot more effectively than just water would.
Mm-hmm.
And steaming mop will disinfect and break some stuff that's stuck on with heat and water.
Yeah.
So I think you're probably good either way. It depends on maybe which room in the house you're using and what you're trying to accomplish.
Mm-hmm. Interesting. I don't think I realized that steaming could also disinfect. I don't know why I didn't think about that. I just thought like...
Because it's hot.
Yeah, I just thought like it could definitely get the dirt off is kind of what I would think. But yeah, interesting. Thanks, Jonathan.
Yeah, that's a good question, Jonathan.
Also, I'm guessing, Jonathan, that from your name that you are Lord of the Rings fan.
Or a wizard. Maybe he's a wizard.
Yeah, or both. Either way.
Well, thanks, guys, for all your questions. This was fun. I always love these Q&R episodes.
Yeah.
They're some of my favorite things we do. So stay safe out there. Listen to all your CDC recommendations and keep yourself and the people around you healthy.
Absolutely. And keep the questions coming.
Also, I want to say we've mentioned a few times, and we also talk about at the end of every episode that we have a Ko-Fi. And we do that because this podcast, even though we've started working on getting some sponsors, still costs Gemini money to make the show.
Yeah.
And as we are nearing a threshold, we're so thankful. We've had so many listeners. We're getting close to 10,000 downloads every single month.
Mm-hmm.
When we hit that barrier, it's going to get much more expensive to host our show.
Yeah, basically the way our host works, this might be more than you care to know about, but where our host works is about how much bandwidth we take up from them, because they're the ones, managing and like having the infrastructure in place to be able to deliver this data to this many people. Mm-hmm. So once we cross that 10,000 download threshold, we go up to another tier basically,
and
which normally
a lot more expensive.
Right. So that's still a thing that we're going to be talking about our Ko-Fi, and a really big reason to try to get sponsors so that we can keep the show coming to you and keep it free and all things that come with the podcast and make podcasts so great. That's why we love them too. So.
Right. And we're committed to keeping our show open access. We don't want to put up a barrier or a paywall or content that's behind something like a Patreon. We want any listener who wants to listen to be able to do so.
Yeah, absolutely. And so since we updated you guys last, Joseph S. has donated a few coffees to our Ko-Fi. So we just wanted to shout him out. Joseph, thanks so much for listening.
Yes, thank you.
And for being generous and helping keep our show going. We appreciate it.
And please consider doing the same and helping us to keep this show coming to you guys.
It's not usually fun to like go into the details of this kind of stuff and talk about, what is required to keep the show going and that things cost money, all that stuff. It's obviously not the fun part, but we just wanted to be transparent with you guys and let y'all know. We talk about our lives, we talk about science, we talk about everything. And so it's also important to talk about what kind of goes on behind the scenes a little bit here and there and let you guys know how we can keep the show going into the future. So that's why we went into it.
But without you, we wouldn't have a show. And we're so thankful that you guys have been so excited and are sharing. We're so happy that we're facing this threshold of getting to 10,000 downloads a month.
Yeah, it's a good problem to have.
It is. And I say it every day, we're reaching our SciComm dreams. I'm living the dreams I imagined for my science communication goals. So for me, it's absolutely worth every minute of doing this. And I'm so excited to have so many listeners who are engaged and communicative. It just means the world to me. Mm-hmm. So thank you guys so much. This episode of Chemistry for Your Life was created by Melissa Collini and Jerem Robinson. And we'd like to give a special thanks to E. Robinson, who reviewed this episode.